Bueno, había pensado coger un vídeo, traducirlo, pasarlo tal, y digo, mira, es más fácil, que lo ponga aquí, me lo veo en lo que ceno y así lo veis todos y queda grabado. Ahora, disfrutarlo.
Before I explain anything, I want you to notice what you are actually seeing. Do you see a sphere? Do you see curvature? Do you see something coming out of a planar surface? Can you notice how your brain wants to answer with a story it's concocting to justify this, instead of answering with what your eyes are actually showing you? This is a flat plane with no curvature. This is not a sphere. It does not wrap around anything. The elevation data goes from 0 degrees in the east to 90 degrees at peak and back to 0 degrees in the west, a total of 180 degrees. That geometry defines a plane. The sun emerges from a plane and it sets back into that same plane. If you're still picturing a spinning globe right now, that image is not coming from this model. It's an assumption you brought with you. In the standard space model, the sun's diameter is about 109 Earth diameters, and the sun's distance from Earth is about 11,750 Earth diameters, what we usually call 93 million miles, an object that is 109 Earths wide and 11,750 Earths away does not rise out of the ground, and it does not set into the ground. What you're looking at here is not a cosmic model. It is a local observer-centric rendering. The ground is fixed. The observer is fixed. The sky rotates as time changes. This is not how an atomistic material universe behaves. This is how a 3D rendering system behaves. Now we stop talking about visuals and talk about what a model actually is. Any object claimed to be moving through three-dimensional space must be described by something called a 6 degree of freedom state vector. 3 degrees describe position x, y, z. 3 degrees describe orientation, roll, pitch, yaw. And if the object is really moving, the model must also include velocity, acceleration, angular velocity, and angular acceleration. This is not optional. Without this data, motion does not exist in the model. These are the models we refer to as our models, not because we built them, but because they only function if Earth is fixed and stationary and the luminaries rise from a plane and set back into that same plane. That is not the claim made by spinning spaceball models, and that distinction matters. The model we rely on most is the Andrew Marsh 3D Sun Simulator. This is the fixed and stationary plane version, the version engineers actually use. It is used for solar panel alignment, building heat load calculations, and precise shadow studies. It outputs solar azimuth and altitude data accurate to hundredths of a degree per second. It predicts shadow length, direction, intensity, and movement at every moment. All of this is calculated on a fixed and stationary plane. If I press play, I get precise solar position data for any location on Earth any day of the year. There is complete data for a sun moving relative to an observer on a fixed plane. and there is zero data for Earth translating, rotating, or accelerating through space. Where is Earth's XYZ position? Where is Earth's orbital velocity? Where is Earth's acceleration? Where is Earth's rotation state? Where is Earth's angular velocity? It isn't there. Now, this same fixed Earth solar model was also visualized on the side of a spinning spaceball. This is the version spinning spaceball advocates point to. The calculation layer did not change. This is the same data visualization and data from the fixed and stationary plane version of the tool. The rotating globe is a visualization layer added on top. As time moves, the data is still only sun azimuth and elevation. There is zero data for Earth's motion. At small scales, roughly 175 miles in radius, you can clearly see the sun rising from Earth and setting back into Earth. The scale increases, the visualization begins to fail in worse ways. We see large regions of negative horizon elevation. The data only exists for 180 degrees. At this point, we see the sun crashing into the side of Earth as it rotates around the observer. At maximum scale, you can clearly see the sun's path is centered on the observer. Even though the sun is making it around Earth without crashing into it now, it is clearly not a sun 93 million miles away. Keep in mind, it is graphically impossible to show Earth and sun together to scale. If Earth were just 1 centimeter wide, the sun would need to be displayed over 387 feet away. And to show just the solar system out past the Oort cloud at the same scale, the screen would need to be approximately 7,300 miles across. There has never been, and never will be, a communicable 2-scale heliocentric model. And none of this even addresses the missing 6 degrees of freedom data. If everything were moving, accelerating, and diverging through space, paths would never repeat. Yet they do perfectly. Look, these background stars are non-dynamic. There is no measured North Star, no celestial South Pole, no moving constellations, no 6 degree of freedom telemetry for any star. They are decoration, not calculated objects. There is something this model shows very clearly. The sun is not moving in this model. The sun is fixed and stationary. And this is the strongest model spinning spaceball advocates can point to. Now let's move on to 2 more models that we openly claim as ours, SunCalc and MoonCalc. These tools are often presented as simple visual aids, but they are doing something very specific. They calculate the azimuth and altitude of the sun and moon relative to a fixed observer. What you are seeing here is a top-down orthographic view of the same solar geometry used in the Andrew Marsh 3D Sun Simulator. The difference is perspective, not calculation. With SunCalc, it's impossible to zoom out far enough to avoid seeing the sun rise from a plane and set back into that same plane. The sun does not emerge from behind a curved surface. It rises into view within an observer's circle of sight, reaches peak altitude, and then sets back into the plane. This motion is entirely contained within the observer's circle of sight. For most people, that circle is realistically about 20 miles or less. When these models are viewed at realistic observational scales, the geometry becomes obvious. The sun rises from the plane, it moves across the sky, and it sets back into the plane. MoonCalc does the same thing, but for the moon. It calculates lunar azimuth and altitude relative to a fixed observer. Just like SunCalc, it's impossible to expand the view in a way that turns this into a spinning spaceball model. The moon rises from a plane, it reaches peak altitude, and it sets back into that same plane. SunCalc and MoonCalc calculate luminary position. They calculate azimuth. They calculate altitude. They calculate rise time and set time. They do not calculate Earth's motion. No Earth XYZ position. No Earth orbital velocity. No Earth acceleration. No Earth rotation state. No Earth angular velocity. Spinning spaceball advocates often claim that SunCalc and MoonCalc are secretly globe models. But a model cannot be something it does not calculate. If Earth's motion is not present as data, then Earth's motion does not exist in the model. These tools only work if Earth is fixed and stationary and the luminaries move relative to an observer. Suncalc and mooncalc are not independent curiosities. They are consistent with the Andrew Marsh model. All three calculate the same thing: luminary motion around a fixed observer on a motionless plane. And when multiple independent tools used by engineers, developers, and astronomers all require the same assumptions to function, those assumptions are not accidental. The biggest model of all that we use and openly claim as ours is stellarium. Andrew Marsh tracks the sun. Suncalc tracks the sun. Mooncalc tracks the moon. But when we want to know where any other luminary is at any given time, we use stellarium. Spinning spaceball advocates insist stellarium is their model. But that claim collapses the moment you examine what the model is actually calculating. When you turn off the ground in stellarium, you can clearly see exactly what is happening. The luminaries rotate around an observer positioned on a motionless plane. As time changes, the only data changing is azimuth and altitude relative to the observer. There is no 6 degree of freedom data for Earth in stellarium. No Earth XYZ position, no Earth orbital velocity, no Earth acceleration, no Earth rotation state, no Earth angular velocity. Only the sun, moon, and wandering stars change position. All other stars remain in exactly the same positions relative to each other. For those of you with good spatial awareness, you will immediately understand that for that to occur, Earth cannot be in motion. Some claim a hidden R value exists within the code of these tools and proves a globe. That value is back engineered from the measured width of the equator, and it does nothing to solve the missing 6 degrees of freedom data problem. If stellarium were a real heliocentric model, you could click on any object and retrieve its 6 degree of freedom state vector. That data does not exist. So yes, stellarium is one of our models, not because we built it, but because it only works if Earth is fixed and stationary and the luminaries move around an observer within a defined circle of sight. Where is Earth's XYZ position? Where is Earth's orbital velocity? Where is Earth's acceleration? Where is Earth's rotation state? Where is Earth's angular velocity? If this information does not exist in relation to an absolute reference frame, it cannot be claimed as a spinning spaceball model. A model cannot be a spinning spaceball model if the spin does not exist as data. If the sun were 109 Earth diameters wide and 11,750 Earth diameters away, what exactly is it rising out of right here? We are not using spinning spaceball models. Those do not exist, and due to the scales involved, are impossible to communicate. We are using observer-centric renderers that do not contain 6 independent degrees of freedom for a moving Earth. If the motion isn't in the math, it's not in the model. These and all other models that show the luminaries rising from and setting into a plane in an observer's circle of sight are models that show how the luminaries work in a 3D rendered virtual reality framework, not in an infinitely expanding spaceball framework. These are our models, not spinning spaceballers' models.
Bueno, pues de eso era la cosa. El estacionario, el Suncalc y la primera que le ha dado más caña sobre todo, que es el tema de que utilizan los ingenieros, el tema de las sombras para calcular las sombras y el movimiento del sol, ¿no? Saludazo a Tohoku, nuestro amigo Wilber. Saludos a Gino Landino. Y saludos al Pablo, a pasar el link. Si alguien quiere intentar refutar algo de lo que se ha expuesto, que lo intente. Bueno, esto lleva 4 años.
Evident that you had a creator. Any flat world has a creator. No person has ever been able to conceptualize existence on a flat plane that had no creator.
Bueno, el tema del creador. Bueno, aprovecho para mostraros que hay mucha tierra plana por ahí. Saludos al DUF, al DUF. Bueno, vamos con el documental. Es bastante largo, yo creo que lo vi. Pero bueno, recuerda un poco lo de las cosas de siempre, casi.
This is an example of augmented reality. And then there are chroma key screens. So outside of green screens, there are also blue screens. And that's what you're seeing right
Nuestro amigo Tim Peake.
here. You're seeing the former president being pushed through this NASA area, and behind him is Tim Peake, an astronaut.
Lo conoce hasta me encanta porque lo llama hasta por el nombre.
And I've only ever found one other video that's ever shown this same checkered blue screen. This is that one other video that I'm showing you right here. But how coincidental is it that they use this blue checkered background, which is extremely similar to ORAD?
Casualidad. Bueno, un clásico aquí.
10 miles away, NASA camera shows moon crossing face of Earth. It says a NASA camera aboard the Deep Space Climate Observatory
Qué
discovered.
recuerdos. A veces viendo un documental de esto ves cosas que dices, ostras, qué menudo tesoro.
Stuff that just doesn't.
Bueno, estoy aquí, creo que se me oye. Saludos a Marí. Bueno.
Seem right when you start looking into it. Like the SpaceX missions. These are landings recorded by SpaceX and published by them. This is CRS 6. This is CRS 8. This is CRS 10. This is CRS 11. Again, this just doesn't look real to me. And how can a rocket steer a landing like this? These rockets are like huge, massive, heavy sticks. If you aren't picking up what I'm putting down, then let me be really blunt here. This feels very similar to today.
Bueno, es bastante larguito y está en inglés, así que vamos a ir a las partes interesantes.
They would see that it looks nothing but flat.
El tema del nivel, ¿no? El nivel
So
del
you have
agua.
these two people, and they're looking out, they both think that they're at the top of this ball. So what's really happening throughout this ocean, throughout this body of water? Can you take a water level to everywhere and it's going to be level? Yeah, of course you know that you could. But what if this is not what's really happening? What if this is what's really happening? And the two people standing on both continents are actually just at water level as well. Wouldn't that be easier to comprehend and understand? Because water always finds...
El tema del agua, súper importante, lo hace muy bien este.
Difficult to explain. Physicists have determined that a rotating wheel has angular momentum, similar to the momentum that a stone flying through the air has. To change the direction of the stone requires a force. Similarly, changing the orientation of the rotating wheel requires force. The spinning wheel prefers to stay oriented as it is, and it resists any attempt to change that orientation. The fact that gyroscopes will maintain a particular orientation in space is very useful. In modern aircraft, an inertial guidance system uses spinning gyroscopes to monitor and control the orientation of the aircraft. The gyroscope is suspended in a special cage that allows it to maintain its orientation independent of the aircraft's position. If the aircraft rolls, electric sensors and contacts connected to the gyro send information to the pilot about the aircraft's orientation.
Now let's go back to my previous example of flying from Japan to California and consider a couple other items. Remember, it's over 5,000 miles of ocean from Japan to California. And the curvature map says that with right at 4,000 miles of distance, there will be right at 4,000 miles of curvature from your starting point to the ending point, assuming that you're actually traveling 4,000 miles of distance. So with that in mind, let's look at my previous mock-up. Here's the airplane taking off. And remember, the Pacific Ocean must be curved based on what we're taught. So the airplane flying across these thousands of miles would need to keep pointing down due to the 5,000 miles of distance and thousands of miles of curvature below. So how can a gyroscope be properly calibrated on a globe Earth when there are thousands of miles of curvature? How does it work when the Earth is always spinning? Is the gyroscope constantly correcting itself? Is it constantly resetting itself? Is it constantly stopping and recalibrating itself? It just doesn't make sense to me when I look at everything and how it works. And here's something interesting that I found at NASA's website. It's a NASA reference publication from the late 1980s about the derivation and...
No, ahora se viene con esto, pero el giroscopio lo ha dejado nítido.
Definition of a linear aircraft model. Let's go through this. There's a lot of math, but toward the end on page 30, the first sentence in the concluding remarks say, this report derives and defines a set of linearized system matrices of a rigid aircraft of constant mass, flying in a stationary atmosphere over a flat, non-rotating Earth. I gotta ask, why would this exist if we're supposed to be on a spinning ball? NASA had already been to the moon several times and explored outer space in many ways by the 1980s. So why would they need documentation talking anything about a stationary atmosphere and a flat, non-rotating Earth? I just don't get it. And of course, I understand that this does not prove anything by itself. There are just so many things out there that when combined, they create a convergence of strangeness that makes your head spin like the Earth is supposed to be spinning. So yeah, all of this stuff is strange because whenever I look out a car, all I see is a flat horizon. Whenever I look out a plane's window, all I see is a flat horizon. Everywhere I look, I see a straight or flat horizon. The Earth appears flat to me based on everything that I can actually observe. And just look at these Bolivian salt flats, which are the world's largest salt flat at over 4,000 square miles. It has an extraordinary flatness with the average elevation variations within about 3 feet over the entire area. And it seems as if stuff isn't really dropping down at a curve out of our view of distance either. Because to me it seems like we can only see a few miles out. And then things start to get hazy, unless you go higher. Because when you go higher in altitude, that's when your circle of view increases, and you can see further out. Except based on the Earth's curvature using this math, the land should start dropping from wherever you're standing on a ball Earth. Even if you're looking 40 miles out, there should be at least 1,000-foot decline due to the curvature, even if it's a small gradual decline for only a mile. No matter what, the math says that the Earth must curve downward, And that means that things farthest out should be dropping or slanting off toward the distance, but videos like these and so many more out there contradict what I'm told is supposed to happen on a ball Earth when I'm observing the distance and objects at the edge of my circle of view. Again, the horizon always rises to the eye level of the observer based on how high or low you are. But as you go further up in the air, you can always see further out into the distance. Okay, I've got just one more quick thing to show you before we move on to the next part. I'd like to ask if you've ever thought about 3D modeling, or video games, or virtual reality programs in general. Because whenever someone is showing you...
Bueno. Ha destrozado la bola un montón. Este documental está bastante bien. Vamos a seguir a verlo. Va a hablar de programas de realidad, porque tú puedes modelar en 3D en un videojuego, ¿no?
And portraying Earth's reality inside 3D modeling or video games or virtual reality, don't they always use flat surfaces and straight and flat horizons? Yes, they use a flat plane environment when presenting you with a simulated Earth. Everything is presented as flat. They don't show curvature or simulate a constantly moving Earth. This is something else to think about and consider. I know that I'm proposing some really challenging views here, so before I continue, I want to pause. Because right now, your mindset probably remains in one of two gears. The first could be that you're still somewhat open to the possibilities of what I've shown you up to this point, but you have a lot of questions about everything, or maybe at least most of it. The second gear could be that you're still disappointed in what I'm sharing, and maybe you're rejecting and discounting most or all of what I'm saying. And maybe you're thinking,
Tranquilo, colega. Ese sentimiento de ahora. Lo conocemos muy bien.
That I may have truly lost my mind, and those thoughts confuse or upset you. Because you're sitting there wondering how I could be open to believing these things. Here's what I'd say to both camps either way. Believe me, I know what I'm sharing here is strange, to say the least. Again, this was not easy for me to consider. That's why I've done my own research into everything that I've shown you so far. That's what led me to research the even stranger things that I'm going to show next.
Las cosas más extrañas. Bueno. ¿Estáis preparados? Creo que no es muy largo y todavía estoy terminando de cenar. No suben, Roberto, no escucho ahí el Ábalos que quería subir. Ahí está el enlace para quien quiera subir, no solo para Ábalos. ¿Lo he puesto? Ahora estoy liando ya, a ver. Aquí. Pegar. Creo que lo había puesto. Sí. Bueno. Seguimos. Igual no estáis viendo los subtítulos porque estoy yo ahí, en medio. Como el jueves, me voy a quitar de pantalla. O me quedo en una esquina. No, ni siquiera saco en una esquina. Así. Vamos con la perspectiva de este chaval. A ver.
It's not easy for me to consider. That's why I've done my own research into everything that I've shown you so far. That's what led me to research the even stranger things that I'm going to show next. But no matter what, whether you're questioning everything or open to anything, I have a feeling that you want me to show you what a flat Earth could actually look like and what it would take for it to actually work, right? Well, that's exactly what I'm going to focus on next. And this next part may end up being the hardest thing for you to consider, process, or accept. So at this point, you know the challenges that I see in this model or simulation. I found this online. It's an interesting approach because someone said, this is a neurological simulation. We're all gamers, souls inside of bodies.
Voy a los gamers. Bueno, lo está diciendo ahora.
The body equals computer hardware, and the soul equals the operating system/software. Our experience is basically that as of a user or simmer. So that's an interesting point of view. But now I want to take a moment to speak to my fellow Christians because I'd like to look at the book of Genesis. Because if you think about what the scriptures really say about this place and how it was created, it shouldn't be that big of a leap when considering that we live in a simulation. Because on the first pages of the Bible inside Genesis chapter 1, it offers the story of creation. And that creation story immediately speaks of how we got here, the order of everything. And I believe it also indicates we're living in a simulation, because it makes more sense to me when I look at it from a simulation point of view. In the beginning, Elohim created the heaven and the earth, and the earth was without form and void, and darkness was upon the face of the deep. And the spirit of Elohim moved upon the face of the waters. And Elohim said, "Let there be light," and there was light. And Elohim saw the light, that it was good. And Elohim divided the light from the darkness. And Elohim called the light day, and the darkness he called night. And the evening and the morning were the first day. Okay, so that's day one of creation. It says the God of the Bible created the heaven and the earth. The sun and moon did not exist here on day one. The sun and moon weren't created and added until the fourth day of creation. So let's go to verse 14 and start reading. And Elohim said, "Let there be lights in the firmament of the heaven to divide the day from the night, and let them be for signs and for seasons and for days and years. And let them be for lights in the firmament of the heaven."
Bueno, aquí está tirando de un tema cristiano para explicar. Me gusta el tema de Génesis, pero vamos a saltar un poco. A ver si sale algo más interesante. No digo que no sea interesante, sino que... No, mira, no creen en el eclipse. A ver por qué.
I believe that this is why we can also see clouds behind the moon. So as of now, I certainly do not think that the sun or the moon are round balls floating in space. And that's why I don't believe the moon is a physical object that we can actually reach by aircraft either. And when it comes to the stars, it seems the stars have been mapped across the entire sky of the Earth. And they cover all of the land that we can travel across inside this simulation, from the North Pole star to the South Pole star. And that's what I'm going to review next, the land that we live on, Earth. Because it is finally time for me to show you a visual representation of how a flat Earth, the sun, the moon, the stars, and everything could actually look, at least based on everything I've researched so far. And do you remember when I shared earlier how there are many half-truths out there? Well, I need you to recognize that when you research the term flat Earth, you'll find a lot of explanations, and the truth often ends up being buried among disinformation. So I want to first show you the popular flat Earth model. It's a half-truth. Half-true in the sense that I believe it's true that the Earth is flat, but it's untrue that this is what it really looks like. So the popular flat Earth model, it uses an azimuthal equidistant projection, or what I'll call an AE map from here out. And this is a visual representation of the popular flat Earth model using the AE map. Unfortunately, when I realized that the Earth could be flat, this was the model that I found being promoted by nearly everyone. And this map says that there is only one pole star, and it's above the center of everything. And there's a dome over this enclosed environment that we live. It also says that Antarctica surrounds our oceans and continents. It basically says that Antarctica is an ice ring wall around the flat Earth. And the promoters of this AE map also say that the sun and moon are only about 3,000 miles away and that they're both doing circles above us. But I've discovered that that's impossible. It can't be happening because the sunrise and sunset declinations prove circling suns and moons to be impossible, especially in the southern hemisphere. Every single person on this earth who has a compass can verify this model is impossible due to the sunrise and sunsets. But I'll admit I fell for this popular flat Earth model, and I'm not proud of that. But it turns out there are some compelling reasons to fall for it. First, most people are looking for answers when they discover that the Earth could be flat, and they often accept the first model presented. So many people don't keep researching, and that means that many people don't test things about this AE map because they assume the person presenting it already did all of that legwork. So those people don't ever confirm simple things like the impossibility of the sunrise and sunset declinations on this AE map. Also, the promoters of this AE map often point to movies as evidence that it's true, because why else would it be in the background of so many movies? They also point out how the United Nations uses this AE map. And this is an interesting one because there's also something called the Antarctic Treaty System. This treaty includes 50 plus major nations, and it prevents civilians like you and me from simply visiting and checking out Antarctica. Wikipedia says, the main objective of the Antarctic Treaty is to ensure in the interests of all humankind that Antarctica shall continue forever to be used exclusively for peaceful purposes and shall not become the scene or object of international discord. And the popular flat earth model promoters say that we're not allowed to visit Antarctica because it's really an outer ice ring that would expose the earth as flat. Obviously, I don't agree with that, and I don't really know why this treaty exists other than what I just shared from Wikipedia. But I know the popular flat earth model does not work, because if their model was true, then we would have a 24-hour sun and a 24-hour moon. Yes, the sun and the moon would never actually set inside their model. Instead, what they claim is that the sun and moon are simply going further away from you, and it's perspective that makes them look like they're setting below a horizon. I'm sorry, but that's not what I've actually observed using my camera. Plus, there's like no video of a 24-hour sun or moon anywhere online. Yeah, you'll probably be able to find a couple of videos trying to support that. Just be aware that they're all either out of focus or straight up doctored videos. And this is one of the newest models being promoted by some popular flat earth folks on YouTube. This model doesn't work for many of the same reasons, and it also no longer makes the earth flat. I truly believe that most of the people at the popular flat earth channels promoting either of these flat earth models are purposefully spreading disinformation. Because if they just kept searching for the truth, then they would discover contradictions and major flaws in what they're promoting. They would see very quickly that their models couldn't work with what we actually observe around us. And on top of that, I found that most of the popular flat earth model promoters, they have PayPal and Patreon accounts, and they seem to be on a mission to make money. Fortunately, there are some people who are really searching for the truth.
Pequeña pausa para enseñaros que esto lleva 4 años en la red. 8. Hostia. Más. Seguimos.
Starting with these two guys that I mentioned earlier, Ronnie Harris and Jason Laufenberg. They're not asking for any money, and they're willing to be proven wrong. They want to be proven wrong if that's the case. And just like me, they just want to know the truth and share it with people. And these guys have studied countless maps, searching for an accurate map that could represent a flat earth. They actually got a tip from something that Neil deGrasse Tyson said, something I already showed you earlier.
So Earth, throughout its life, even when it formed, it was spinning, and it got a little wider at the equator than it does at the poles. So it's not actually a sphere, it's oblate, and officially it's an oblate spheroid. That's what we call it. But not only that, it's slightly wider below the equator than above the equator.
A little chubbier.
A little chubbier.
Yeah.
Chubby's a good way. It's like pear-shaped.
Yeah.
So they thought maybe the flat earth could be oblate in some way. That's when they discovered the oblique Mercator projection. And cartographers seem to agree that it is the most accurate flat representation of Earth. But first, what's cartography all about? Okay, so we're here at the Canadian Cartographic Association, and it says that the International Cartographic Association defines cartography as the discipline dealing with the conception, production, dissemination, and study of maps. Cartography is also about representation, the map. This means that cartography is the whole process of mapping. Cartography is a complex and ever-changing field, but at the center of it is the map-making process. Viewed in the broadest sense, this process includes everything from the gathering, evaluation, and processing of source data through the intellectual and graphical design of the map to the drawing and reproduction of the final document. Once seen as the products of a relatively straightforward practical exercise, maps are now viewed as complex intellectual images offering a rich potential for scientific investigation. Cartography today has 2 essential characteristics. First of all, it is important. Maps perform a fundamental and indispensable role as one of the underpinnings of civilization. Few activities relating to the Earth's surface, whether land use planning, property ownership, weather forecasting, road construction, locational analysis, emergency response, forest management, mineral prospecting, navigation. The list is endless, would be practical without maps. Okay, now let's go to World Maps Online. You'll see this is a World Satellite Image Map. It's the oblique Mercator projection that I just mentioned. And it says, this stunningly detailed satellite image map of the world detailed land cover data depicted in an oblique Mercator projection. The parameters of this map projection have been carefully chosen so that the inevitable distortion that occurs is relegated to the oceans and to the least populated and least recognizable land masses. And it goes on to say the result is a unique, visually interesting flat map of the world that exhibits nearly no distortion in the most familiar areas, even at the poles. Let's read that one more time. The result is a unique, visually interesting flat map of the world that exhibits nearly no distortion in the most familiar areas, even at the poles. And now I'm going to play some video where Jason and Ronnie, they walk through a flat Earth map and how it could actually work.
When you look at this map, what looks different to me is Alaska and this part of Russia up here.
Yeah, Russia too is crazy big.
Yeah, this island over here just seems, whoa, crazy.
Yeah, it's huge.
And yeah, this string of islands. So we are told by this map manufacturer.
Bueno, este es un mapa que estuvieron promocionando en la época. Pero era otra alternativa, ¿no? Y me gustó cómo lo explicaron aquí, porque explicaban que por eso te ponen dos polos sur en el modelo de la Tierra, ¿no? Pero esto sería también un mundo así como que se repite. Más básico de alguna manera. Y han evolucionado esta gente también. Y bueno, por aquí ya creo que alguna cosa más pone.
You need to seek the answers to your own questions so you can confirm or deny the validity of these strange truths. Doesn't
Ahí está. Hacer vuestra propia investigación, chaval. Sobre todo quería ponerlo de San Calque y demás. Este directo era para eso, para ver si alguna persona tiene preguntas. Voy a leer, a ver. Bueno, saludos a todos, ahí os dejo por hoy. 43 minutos, no está mal. Adiós. A ver, aquí, finalizar. Adiós.